It is Decentralized by encouraging.
Sir, am I audible, sir?
Yes, yes, you're audible. Wait, mute correlation.
So shall I start the session, sir?
Yes, yes, you please.
Good evening to all the distinguished participants, respected speakers.
Sorry for the interruption. Okay. Now talking about the cryptographic hash function, hash it is one of the most important part of a blockchain actually. So basically what it means, hashing is the process of converting an original piece of data into a digest or a hash values. The process uses in cryptography hash function for the irreversible conversion of the messages. So before storing the data into the blockchain, right, so whatever data, whatever piece of data that you want to store into the blockchain, so for that we need to create the hash values. So there are different online hash generators are available. With the help of that, we're going to convert your complete data into a 256-bit hash value, right? So suppose just take an example. Suppose I want to store a hello. So for hello, we need to generate the hash value. Suppose in online and platform that you want to generate the hash value, just you need to put a digest. That means whatever things you want to store into the blockchain. First of all, we need to create a hash value for that. So suppose I want to generate the hash value for hello. So the hash value is for hello is 334D016. Likewise, this is a total hexadecimal uh, hexadecimal format. So it is a 256-bit hash value that we can generate with the help of online hash generator actually. So for any sort of digest, there is not a single words we can generate a particular hash value. Suppose if we have a code of 1,000 line, and or we can say if I have a one particular paragraph, and for that particular paragraph I want to generate the hash value, so just you need to provide your particular data to the hash generator, and your hash generator will provide a constant 256 bit or 256 bit hash value for your data. So it is deterministic. That means suppose deterministic means what? Suppose HELLO hello is there. Now your hash value is this one. Suppose I'll put H is that H is capital, I'll put H is small, so your hash value is different. It is deterministic, right? So it is not a matter how much amount of data you want to generate for particular, how much amount of data you're providing for the hash value. Whatever data you need to provide, whether it is of 1 MB data or a 2 MB data or a 5 MB data or a GB data or in data in the form of TB. So every time whatever data you are providing, so you will get a constant at 256-bit hash value, right? And it is irreversible. That means with the help of hash value you're not going to generate your original data. That means if I have generated this particular hash value for hello, so with the help of this particular hash value we are not going to generate hello. So that is the main important point for blockchain. So while creating the hash value for a one particular data, we cannot reverse, or we cannot find the actual data from your hash value. So that is the main role of hashing in the blockchain. Now there are different cryptographic hash function that we can use for generating the hash values. The hash function applies to the messages in order to generate the message digest, which is a fixed size of hexadecimal output. So it means that it doesn't matter if you send one particular paragraph, if you send a 10 line 100 line of code, if you send a 1,000 line of code, then also your hash value should be of 256 bit only, right? So your data size doesn't matter. Your hash size, whatever data you are providing, your digest should be equal to the 256 bit only. So it takes a arbitrary size input as message that I have already told you. The data size can be of anything, but your actual digest is of only of 256 bit. Uses a cryptographic hash function h to be encrypted using the message m. So that means h of m is equal to digest, so m is your message. So whatever message you are providing to the generator for finding the hash value, you will get a digest of 256 bit only. So there are different kinds of algorithms are there. We have a SHA 224, we have a SHA 256, we have a SHA 512, we have a KEKAK 256 and Whirlpool. So these are the different algorithms, these are the different cryptographic hash functions. So just I have taken the example of 256 bit. You will take the 224, you will take the 256, you will take a 512, you will take a KEKAK 256. So what happened with, you are using a particular algorithm for generating the hash value. According to that, your hash get generated, whether it is 224 or 256 or a 512, right? According to that, whatever algorithms you are using for a hash generation, so that much amount of bit you will get in the digest form. That the digest is called as in your hash value actually. Now, how to generate the hash value from any sort of digest, or what we can say, any sort of data, not a digest. It is basically hash value itself right? We can say hash value, generated hash value, it is itself a digest actually, right? So suppose if you have a numbers, if you have suppose text file, if you have suppose image file, if you have suppose video file, if you have suppose audio file, right? So any of them data you can send to the hash generator. It may be of a number, it may be of a text, it may be of a multiple records, it may be of images, it may be of your audio file, it may be of your video file as well. You need to send in the form of message actually. So whatever message you are pass into the cryptographic hash function, so it will generated your digest, and that how much amount of bits would be there in the digest, it is totally depend on the type of hash functions you are using. It is MD5, it is SHA 256, it is SHA what we can say, it is SHA 224 and KCAC 256 likewise. And after that you will generate the digest, or we can say it is digest, it is also called as a hash. So there are different, you can check it, there are different multiple online hash generators are already available, right? Uh, one of the three links are mentioned on the screen actually. One is free formatter, it is one of the hash generator, online hash generator. One of the is online web toolkit is there. Another is a text tool suite is one of the hash generator is there. So these are the different sample platform through which we are going to generate the hash value for any sort of message. For any sort of message, we are going to generate hash or a digest. So with the help of different platforms that we can check it. But the major concern is once you find out, or once you generate the hash value, suppose if for example we have generated this hash value, that it is displayed on the screen, displayed here in the diagram. So with the help of this particular hash value, we are not going to reverse the messages from the hash value. That means with the help of hash or with the help of digest, we are not going to find out the actual data. That we cannot think if I pass this text to the hash generator, that text file, that particular hash generator will provide it the one particular hash value. And if you are thinking with the help of that particular hash value we are going to find out the text reversely, so it is not been possible, right? That is a major concern with the hash functions actually. Now, the another concern is how the blockchain technology actually work, right? So, if we talked about the blockchain, so blockchain, it is a collection. It works in a peer-to-peer networks. Actually, there are a lot many nodes are there in a P2P fashion. Actually, suppose if any user want to initiate any sort of transaction, the transactions want to record it to the blockchain. The very first and foremost thing is the user wants to initiate the transaction. The very first and foremost thing, the very first step, that you can say first step, you need to initiate the transaction and broadcasted into the network actually, right? We need to create a transaction, initiate the transaction, that that transaction get floated or broadcasted in the blockchain actually. So that particular transaction it reaches to all the nodes, right? And after that there are some validators, there are some miners to validate the transaction actually. Suppose if we are using a Bitcoin blockchain, so in that particular case the what we can say, the validator, or we can say who is going to validate your transaction, so that validator is called as a miners in case of a Bitcoin blockchain. But suppose if you are using a Ethereum blockchain, so in this particular Ethereum blockchain, so miners term get changed into validators. So in Ethereum we can call it as a validator. In Bitcoin blockchain we can call it as a miners actually. So who will be going to mine the particular transaction, that is known as a miner. And in case for Ethereum blockchain, who is going to validate the transaction is called as a validator. So validation is very much important. And who will be going to validate that particular transaction, so there are different miners, different validators are there in between this. So we need to validate the transaction. Suppose if in particular network we have 100 miners are present, and out of 100 miners or 100 validators, if one of the validator mine the transaction very first. So if the particular transaction get mined by some validator or miner, it is provided to all the nodes available in the network, and we need to take a voting from that. So whether that particular transaction is validated or not, and 51% weightage should be given to the voting. So it means that if the 51% and result we will get, so it means that that particular transaction is validated or mined by the particular miner. If it is validated, then that particular data or a record get stored into the blockchain. That means that transaction is complete actually after mining your transaction, or validating your transactions, and after getting the approval from the different nodes connected with the blockchains. And then lastly, we need to add the transactions into the blockchain actually in the form of blocks. So this is actually the work of blockchain. Now, what is the role of consensus mechanism actually? That is a new word, but it is not new. The consensus means it is a protocol that we need to follow for mining the transaction, for validating the transactions actually. Now, if we talked about the hello, anyone please confirm my screen is stable or moving? Anyone please confirm?
Sir, it is stable, sir. Ah,
It
sir,
is
now it is moving. Yes, sir, now it is moving.
it is moving, and now previously it is what it was on a first slide.
Sir, now it is on the 11th stage, sir.
Now it is moving. Oh,
Ah, yes, sir, yes,
sorry,
sir.
sorry. Actually, sorry.
Okay,
Yeah, I thought
okay,
it was moving. I haven't seen any messages. No, that's fine.
okay,
Yeah. All right,
okay.
all right. Sure. Now, which screen is there on the screen? That consensus mechanism.
11th. Ah, yes, sir, yes, sir.
Okay. Now, consensus mechanism is very much important actually. Now, if we see the consensus mechanism, it is nothing but it is not a new, it is new words for the blockchain actually. But consensus means that protocols we need to follow, right? So basically, what means a consensus mechanism? When any user initiate the transactions, then how the transaction get mined, how the transaction validated by the validated the particular transactions by the miners, or we can say validators, that we need to decide. So there are different sort of consensus mechanism that we need to adopt in the blockchain actually, and it is totally depend on the type of blockchain we are using, right? So if we see the consensus mechanism, at the very first level we have a transaction verified by the first verifier. We need to float, we need to broadcast your transaction in the network, right? So once the transaction is verified or mined by miners, that verified transaction get broadcasted in a blockchain network. It is provided to everyone. Then all other verifiers need to see the verified transactions. After that, if it is verified or 51% voting is done successfully, then transaction get added to a blocks, and block is added to the blockchain, and finally the transaction is finalized. This process we need to follow actually. While talking about this process, so there are different consensus mechanism that we need to use. It is totally depend on the type of blockchains we are using. Now please let me know on the screen, proof of work is there? Anyone please let me know.
Yes, sir.
Okay, thank you. So now this proof of work, or we can say a consensus mechanism, it is totally depend on the type of blockchains we are using. So when blockchain was started, the at the Bitcoin blockchain, or when we have used blockchain for cryptocurrency, so at that time we've used to proof of, that means that we are going to use proof of work. It is one of the consensus mechanism called as proof of work. So Bitcoin is the most famous implementation of POW, and we'll use it to explain the concepts actually. So basically, what it means, a proof of work consensus mechanism. So what happens? Suppose if you have a P2P network, peer-to-peer network, right? So in P2P networks, there are some miners are there. That means miners means what? Who are going to mine your transactions. That means who are going to validate your transactions or identify whether your transaction is proper or not, right? Whether we are getting the transaction from the what we can say authorized person or not. So we need to validate that transactions before adding into the blockchain. So if the particular in particular network we have a different miners. So what is the role of miners actually to validate a transaction, right? To provide the validation over on a particular transactions actually. So it means that if you're talking about the POW, proof of work, once the transaction is initiated, the transaction is floated for all the miners. It is given to all the miners. For example, in my network, I have a 10 miners. So that particular transaction is that particular transaction is floated for 10 miners. So every miners is parallelly working on that to validate that particular or to mine that particular transactions actually. So in this particular case, what happens if the 10 people are working at the same time? So say if the 10 people are working parallelly, so it computation task is more actually, right? So in POW, what happens if all 10 people are working at the same time and out of that 10 people, the very first miner that mine the transaction very first, that particular miner will get the reward points in the form of bitcoins actually. So out of the 10, one miner will get the reward points, but other 9 miners are working on the same, so they have waste their resources, they have waste their time. So it means that there is a problem for POWs, that it is floated to that particular transaction is given to all the miners for mining it, but any one miner get a chance to mine that particular transactions and will get a reward points, right? So that type of a POW mechanism is used in a Bitcoin for validating the transactions actually. But after some time, when Ethereum come into the picture, that the another consensus mechanism was used, that is POS, called as proof of stack. So instead of POW, that Ethereum blockchain was work on proof of stack actually. So basically what it means, a proof of stack. So in POW, when the transaction initiated, the transaction given to all the miners for mining purpose. But in case of a proof of stacks, we need to prepare a stack of miners, those who are really interested for mining that particular transactions. And suppose if I have a 10 miners, and sorry, in case of Ethereum, we are not saying miners, we are saying validators, right? So suppose if we have a 10 validators, now out of 10, that 5 people are really interested to mine that particular, to validate that particular transactions. So what happens, that 5 validators need to put some sort of a cryptocurrency in the form of stack. So in stack, 5 people will put their own bitcoins, right? So out of that 5 validators, we need to choose anyone, we need to choose anyone to mine, to validate the particular transactions. So if that particular validator validate the transactions, so it means that that particular validator the uh, will get the uh, bitcoin, what we can say, a cryptocurrency in the form of rewards, or uh, what what we can say, the parallel computation, or parallel computations, it is not required in POS, or we can say Ethereum. So in case of a POW, all miners are working for the same, but in POS only, that we need to prepare a stack of validators, and out of that we need to choose one, and that particular one validator will work on that actually. So this type of a mechanism that we can use for Ethereum blockchain. At, after that, there are other consensus mechanism is also there, that we have a proof of burn, that proof of elapsed time is there, proof of activity is also there. So these are the again different types of mechanism that we can use. It is totally depend on the type of blockchains we are going to use. So other consensus mechanism is also there. Now talking about the hyperledger fabric, it is very much important. So basically, what happens with the hyperledger fabric? So hyperledger fabric, it is nothing but what we can say, it's an environment, it is a framework that provided by the different companies, or different foundations, what we can say, right? So basically, when it was in hyperledger fabric came into the picture, so the Linux Foundation and IBM, that IBM and the Linux Foundation was firstly introduced the concept of hyperledger fabric. So basically what happened with the blockchain, if we talked about the blockchain, so that immediately immediately the things come into our mind, that blockchain means that it maintains a transparency and immutability, so everything will be known to everyone. But suppose if we want to create a blockchain, or if we want to use a blockchain for one particular organization, the organization will think for that, why this particular organization is of mine, why I need to show my details, of why I need to share my information or my organization information with the other ones. That is the question mark, because in public blockchain we need to show each and everything with everyone because it's a public. But talking about a private or consortium, so for that we need to use a hyperledger fabric, we need to use a particular platform. That platform can be used to create a blockchain for a one particular organization or a group of particular organizations, right? So it is basically a permission blockchain framework. That means in this particular hyperledger fabric framework, that it is not been like that that everyone or anyone can join the blockchain, any node can enter into the blockchain, right? So for adding or for entering into the particular blockchains we need to take a permission, and from the consent one for adding into or taking the use of or taking a part of this particular blockchain actually. So we need to use a hyperledger fabric, so it is actually the environment. So there are different sort of companies or different type of industries nowadays are there. They're coming with a different hyperledger fabric. I will tell you in the coming slides actually. So basically when we use a hyperledger fabric, basically it is used for a different sort of properties actually. So for that particular kind of things we need to use the hyperledger fabric in a business form. So unlike public blockchain like Bitcoin and the Ethereum, fabric is designed specifically for a business use cases where the organization need. One is controlled access, that we need to control the access, because we are not going to provide access of each and everything to each and everyone, each and every member of the organizations. Then it is high performance, then low latency, then confidential transactions, then modular architecture. So these are the different what we can say different features that we can incorporate it integrated in a hyperledger fabric for, because that particular blockchain or that particular concept we are going to implement in for a business point of view or for an organization point of view. Now, the another thing is how hyperledger fabric actually work. When we talked about a peer-to-peer networks, there is a certain types of peers as well, right? So if we talked about the hyperledger fabric, so there are different peers like endorser peer is there, anchor peer is there, and a general peer is there. Now, suppose if there is a company A that you can see on the that you can see on the screen, so that there is a company and company B. So company A peers wants to communicate with the company B peers, so that you can see the that orange color peer named as an endorser peer, that blue color peer that named as anchor peer, and after that that gray color peer is named as a general peer. These are the different categories of the peers that are used actually. So these are the different peers. Suppose company A are having the different kinds of peer, company B is also having the different kinds of peers. So the role of peers is used to initiate or maintain the transactions into a blockchain for a one particular organization actually. Suppose you can see in a one company A diagram, the peer that is orange color peer that is called as endorser peer wants to initiate the transactions with the one particular client app or a one particular fabric. So he need to initiate and stimulate the transactions actually for company B. So peer one, that orange color peer in the company A, initiate and stimulate the transaction. It is going to the ordering peer, peer going to connect the things with your company BPS, right? Now you can say suppose endorser peer, basically it is used for making and stimulating the transactions with the peers of the other company. Now anchor peer are there. Anchor peer, it is represented with the blue color. So basically the role of anchor pair is to see the transaction and and prepare a record in the form of DB into a blockchain actually. So that is the main role of your anchor peer. They are not worried about it validating the transaction and all. So they are just worried that means sorry, that anchor peer, it basically used to validating the transactions. Once it is validated, it's your normal or a general peer, it is used to store your transaction into the DB or in the blockchains actually. So likewise the hyperledger fabric works. Now I'll tell you how peer types in the diagram will work. That you already seen in the last diagram, that orange color peer named as endorser, blue color named as anchor, and a gray color named as a general peer. Now see the endorser peer is there, that orange color. It is basically endorser peer is responsible for simulating and endorsing the transactions. Suppose if you want to initiate the transactions, we need to simulate the transactions. So the role of endorser peer is to prepare or prepare a transactions, or we can show initiate a transaction. And ensure the transactions follows the chain code logic actually, that we need to follow the chain code, that every transactions we need to follow the chain code is very much important. So chain code logic, we need to find out the chain code logic that would be followed by the endorser peers. Another is anchor peer. So we have an anchor peer. It is basically used for communication bridge between the organization. Suppose organization A is there and organization B is there, to maintain this particular transaction route from company A to company B. So your anchoring peer is used to prepare a breach for that communication breach. After that, we have a general peer. It is used to store, it is used for storing purpose actually. It is the role of general peer is used to store the data into the ledger format actually. And ordering peer, it is a green color, that you can say ordering peer, it is shown by the green color in this diagram. So now ordering peer, it is not a peer in the normal sense. It is orders transaction and create the blocks. Basically ordering peer, it is used to create it order the transactions and create the blocks. So it is basic purpose of ordering peer is to create a blocks actually for storing the transactions. Now how actually the that what we can say hyperledger fabric works, what is the workflow for that? So when it that is the very first point, that client sends a proposal. First of all, we need to send a proposal. Endorser peer simulate a transaction, that we need to simulate a transaction through the endorser peer. Then after that, client gets the endorsement, will get the endorsement, right? Then client send the endorsement transaction to the ordering services. Ordering peer is there. Now orderer creates the block, then block deliver to all the peers, and peer validate the transaction and ledger update everywhere. And once the transaction get added into the block, so that every ledger it is available with each and every node will get updated. So this is actually the process. This is workflow we need to follow. Then talking about the next generation blockchain framework is very much important actually. So from 2020 onwards, right, till the 2020, we that blockchain talked about uh, what we get 4.0, 4.0. But now the feature of blockchain, that we can say that it is a blockchain 5.0. Now we are in the era of blockchain 5.0 actually. So when it was started, so we have been use hyperledger fabric 2.x actually. It is one of the hyperledger fabric. So it is a permission enterprises blockchain designed for organization that need a privacy, controlled access and high performance. It uses a modular component like pluggable consensus and supports a private channel between the participants actually. So hyperledger fabric 2.x, it is basically used for a permission enterprises blockchain. Then after that, ethereum 2.0, it is one of the well-known blockchain that used widely used in the market actually. So where the proof of stack is used basically. So there are two things, that is sharding and rollups. So basically sharding means what? Sharding means shared, and rollup means it is a multi-layer to support a large scale decentralized applications. So we have to use a proof of stack for sharding and rollup. So it is a ethereum 2.0, right? After that, we have another type of hyperledger fabric, what we can say hyperledger fabric environment, that is a Polkadot. So basically Polkadot, it was invented by Parity Technologies and supported by Web3 Foundation. So it is a multi-chain framework where the many individual blockchain called as parachain connected to a central relay chain. This allows a different blockchain to communicate and share the security, enabling a fully interoperable ecosystem. So basically, a Polkadot, it is basically used for suppose if you want to connect a different multiple organization with a different kind of what we can say different kind of areas that we collect together, or for forming a blockchain. That means if there are five organizations are there, and five organizations are decided to create a blockchain in that would be shared by all these five organizations. So the Polkadot, it is used widely, right? So basically it is invented by the Parity Technologies actually, and it is fully a interoperable ecosystem that we can use easily. It is very much handy actually. Another type of hyperledger fabric that, right, that is one of the hyperledger fabric. It is used widely used by widely used by the different industry, that is Cosmos. So basically Cosmos, it is a tender minutes incorporation. Now it is called as Ignite. So it is one of the company that founded with the Cosmos framework for hyperledger fabric, supported by the interchain foundation that's called as ICF, that it is known as an interchain of a blockchain. Cosmos allows a different blockchain to interact using the IBC. So there is a IBC called as inter blockchain communications. So inter blockchain communication means we means what? So there are different kinds of blockchains are there, and multiple blockchains are communicating with each other, called as interacting using IBC protocol. It uses a tenderments consensus. Now, as we already talked about the POS and a POW, but in case of a Cosmos, we need to use its own consensus mechanism called as tender merit consensus for fast, secure, and scalable network. So instead of POW and a POS or the other consensus mechanism, the Cosmos will provide its individual consensus mechanism, right? So that we need to use. After that, we have a Avalanche Hyperledger Fabric, one more, that's Avalanche Fabric. So Avalanche Consensus Protocol was first introduced by the pseudonymous research group called as Team Rocket, and later implemented and expanded by AVA Labs actually. So basically it was first invented by a group called as a Team Rocket. So Team Rocket group find out a fabric known as an Avalanche, and it is expanded in the AVA lab actually. It is highly scalable and low latency blockchain platform using the Avalanche consensus and Snowman protocol. It supports the thousands of transactions per second, and it allows the custom blockchain network called as subnet. So where we need to use a subnet, that as we already heard about in computer network, we have a network and a subnets actually. So we have a group of different subnets collect together, forming a large network actually. So Avalanche, it is used for a fast processing transactions, and what we can say, a thousand of transactions we can process in a second actually. After that, another type of fabric is Algorand fabric. That is a pure proof of stack blockchain actually. Here, like in Ethereum, we have used a POS. So same thing, Algorand, it is also used a proof of stack blockchain, offering an instant transaction finality, making it ideal for digital currencies, asset tokenization, and enterprise application. It emphasizes speed, simplicity, and the security actually. So this is one of the fabric that we can use POS consensus. And another one is Celivio Micali. It is one of the fiber that we can use for implementation of blockchain for business point of view. The inventor of Celio Micali is Algorand insurance, that Algorand foundations, the developer and maintainers of the Algorand platform actually. So basically these are the inventors and supporters of Algorand actually. Then now talking about the Solana and Near protocol, these are the again two different fabric. Solana and Near protocol, it is near about same actually, but it is invented by some other different and what we can say inventors, right, and companies. Now talking about the Solana. Solana it was provided or created by the Solana, it is one of the name of the industry. Then lab founders are Anatoly Yakovenko. This is actually the founder for Solana. Basically, it is used for high performance blockchain using proof of history. So proof of history, it is one of the consensus mechanism that is used by the Solana actually. It is combined with a proof of stack. So proof of history, and in combination with proof of stack, or in combined with proof of stack, it is used in a Solana framework actually. It is known for ultra fast transaction. So it will take a very minimal time, below of seconds, it will use Solana. So Solana basically known for a fast transactions actually. Fast transaction actually, it is having a very low fees and suitable for DeFi, that is decentralized finance and web3 applications actually. After that, the Near protocol, it is one of the fabric that we can use. It was created by the Near collectives. The founders are Ilya Polosukin and Alexander Sikidano. These are the two founders that they have found the Near protocol fabric, a developer friendly shared blockchain that automatically scales as the demand increase, and it uses a nightshade sharding to support the large scale decentralized apps, where Near protocol will be used actually, where the large scale decentralized application, where that what we can say, the decentralized applications are used at a large platform on a such particular kind of things, that we can use a near protocol along with the Solana as well. Now you can see in the this particular picture on the screen, so this is the actual evaluation of a blockchain technology. So it was started in 1991, but the first paper was published published by Satoshi Nakamoto on a white paper in 2009. So the very first thing was developed called as a Bitcoin blockchain. It is 1.0. So at that time, the cryptocurrency and application of Bitcoin were was heavily used, right? So in 2009, the people were used blockchain for what we can, for using the cryptocurrency like Bitcoin. After some year of time in 2015, the Ethereum comes into the picture, and that particular thing is called as blockchain 2.0. So in Ethereum, we used smart contract tokenization and virtual machine, where basically these are the different areas that will be integrated for a Ethereum blockchain 2.0, along with the consensus called as proof of stake actually. So blockchain 2.0 came into the picture in 2015. Now after some new features that would be added into the blockchain, or that would be found by some different companies. In 2018, the blockchain 3.0 was came into the picture, and where the DApps called as decentralized application was invented, or decentralized application was used. In that we have use of web apps, APIs, middlewares, system security, business and financial industrial services, cloud computing, and chatting messages, EOS, IOs, hyperledgers, and a DeFi called as a decentralized finance applications, decentralized application browsers that would be used in blockchain 3.0 in the year of 2018. After some period of time, the that again the invention happened. Again the new features, new cutting edge technologies were added into the blockchain 4.0 in 2020, right? So after that in 2020, so blockchain that we're using AI along with the IoT, along with the cloud computing, along with supply chain in different supply chain management organization or eras, or we can say logistic. So in ERP application, voting system, payment gateway, so we have been used a blockchain 4.0 actually. So now 2020 to 2025, the blockchain 4.0, now the people are talking about the blockchain 5.0 as well. So in blockchain 4.0, we talked about the age AI, that we are talking about a 6G, we are talking about a federated machine learning, then smart government, poverty, smart cities. So these are the different areas where the blockchain 5.0 works actually. So nowadays many of the companies are moving towards the blockchain 5.0s, because everyone will be focusing on transparencies and security, because these are the two major concern for using the blockchain concept. So it provides the high security and it provides a high transparency. So because but the major concern is that we need to go with a public blockchain and a private blockchain. If you're going with the private blockchain, so that access permission, or we can say there is a center authority would be there to controlling the transactions. But if we are going with a public blockchain, so center authority will be completely removed. We are not going to control any sort of transactions in the public blockchain actually. So in public blockchain, anyone can say anything, that is a common slogan for public blockchain. But in case of private, so that in private we can put our own center, we can put our own consensus, we can put our own we have our own that means we have an own central control over on the transactions or a data in the blockchain actually. So this is the evaluations, and now we are serving in the blockchain 5.0 actually. So this is the complete evaluation of blockchain. Now these are the different examples, that the different case studies that I have been included in the today's presentations, that blockchain, it is heavily used in finance, that many of the finance organizations are moving towards, that are using the blockchain concepts, right? So basically nowadays, if we talked about the finance sector, so there are some issues with the finance sector. There is a slow transactions. If you want to send or transfer the money from money or what we can say, if you want to do the transactions at the international level, so it is quite difficult, because it is time consuming process. Because if you want to transact some sort of transactions at the international level, it will take 2 to 5 days, right? It required a high processing fees, it required a multiple intermediaries also, right? So if we think for all of these points, so if we talk on a blockchain, so blockchain provide a real time settlement. It is a very low fees. It doesn't require no intermediaries, and it is a transparent process. That means you can see actually how your transaction is processing and how it is reaching towards your destiny, actually reaching towards the recipient side actually. So for blockchain in finance, we have to use a different sort of framework. We need to use a Ripple framework called as XRP Ledger, called as built for cross-border bank transfer. Another fabric is Settler, that we can use a framework for Settler, that micro payment and a global remittances. And last one is Ethereum, that is stablecoins USDT, USDC, used in a DeFi payment called as decentralized finance payment. So these are the different framework that we can use for the finance sector actually. After that, if we talked about the finance, so there are different areas in finance where we can actually integrate the blockchain concept for the security, transferability and immutability actually. So one is banking sector, another one is payment and fund transfer. Under the banking, we have operations for payment and fund transfers actually. So for that particular purpose, we made a blockchain. After that, asset management, for that also we can use the blockchain. Document management, so in case of a banking sector, in case of finance, there are a lot many documents, there are a lot many that means we need to deal with a lot many documents. So for managing the documents, for providing the transparencies or providing the security on the documents, we can integrate the blockchain into that. We have a trade finance, and after that we have a insurance. So we have a different kinds of insurance for that, for maintaining the records, for promoting our insurance, for or making the for what we can say, for making the insurance in a transparent format with the end users and with the bank itself. So that we need to prepare that we need to integrate the blockchain in insurance as well. After that, how blockchain works in agriculture. So like blockchain work in a finance, similarly blockchain that we can use blockchain for agriculture also. So that farmers data that we can integrate, that seed quality data, that soil moisture data, then climate environmental data, harvest and yield data, demand and price data, that all of these are the different areas related to the agriculture where the blockchain actually we can integrate for making the transparency, security and immutability. Where once the data get recorded, that data can be very much secure, that data can be a very much authenticated, is used by some other parties as well. So so there are different areas in agriculture side also there where we can integrate the blockchain concept with the different types of technologies that we can club AI with the blockchain, with that we can and club IoT with the blockchain in case of agriculture as well. After that, there are some use cases with the healthcare also. So nowadays healthcare is also using or moving towards the blockchain, using the blockchain framework. So as we already know, in case of healthcare, we have a patient data, we have a medical credential tracking data, we have a smart contracts, that we have a drug supply chain management, we have a medical procedures, we have a different sort of a different disease related activities happening into the hospitals. So all of these things are gathered together, or we can say all of these things that we can use or integrated with the blockchains for maintaining or for enhancing the security on all of these things are get gathered together into unified platform, where everything will be that what end user as well as the peoples are using in the healthcare features, that they will get the information on a single point, right? So these are the different areas where the blockchain can be used. So not healthcare, not only finance and not only agricultures. So there are different that you can add the blockchain in educations as well, that you can add the blockchain in other areas as well, where actually the transparencies and security is required. So where in every area we can integrate the blockchain concept, we can integrate the blockchain technology. So uh, we can integrate the blockchain technology for enhancing the security as well as making the integrity as well as the transparencies into the transactions actually. So this is all about the blockchain and the evolution of the blockchain, and whatever framework that we can use in nowadays or in futures as well, that all of the things have been elaborated today. So this is all from my side. So thank you all. Thank you for patience listening. So the forum is open for all. If anybody wants to ask any sort of questions, so please.
Participants, if you have any queries, you may ask.
I request the participant, if you are having any sort of questions, so please put your question in the chat box, or else unmute yourself and please ask the questions, or else kindly raise your hands and I'll unmute yourself. Anyone is there?
Participants, we can have your queries now. Sir, shall we move to the vote of thanks?
Your voice is not audible properly. Can you please put your question on the chat box so that I'll be answerable?
Thank you, sir.
Thank you, Pratika. Thank you.
Sir, shall I move to the vote of thanks?
Yes, 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 you please, please, please. Yeah. If any
Yes,
participant don't have any question, then we can go with the vote of thanks. Actually, yeah.
yes, yes. On behalf of the Indian Society of Research and Development Professionals, ISRDP, I express my heartfelt gratitude to everyone who have contributed to the success of today's seminar on next generation blockchain frameworks and applications. A sincere thanks to Dr. Jagdish Trippal sir for delivering an insightful and highly informational session. Your expertise has provided valuable perspectives on blockchain innovation and its emerging applications. We truly appreciate your time and contribution. We extend our appreciation to all the participants for your enthusiastic involvement and for making this virtual seminar meaningful and interactive. Your presence and engagement motivate us to continue organizing such impactful knowledge sharing events. A special vote of thanks to the organizing committee, the technical team, and the support staff for their seamless contributions and coordinations to the dedication for efforts behind the scenes. Thank you all once again. We are looking forward to continue participation in your upcoming programs and innovatives. Thank you, sir.
Thank you so much. Thank you all the participants as well as the organizing team for inviting me, and thank you participants for your patient listening. Thank you all. Should I wind up the meeting?
Yes, sir, sure, sir. Thank you so much, sir.
Okay. Thank you so much. Thank you so much. Thank you so much all.
Thank you, sir.